Welcome to our session today. I am Daniel Stuckey, the Cisco Program Lead here at Madison Technologies. We're joined today here by Amit Raj and Ash Khan, and we welcome you to today's session. Some housekeeping for today's presentation. For the best experience, we have muted microphones for the duration of the presentation. If you have any questions, please feel free to post them in the Q&A panel, which is supported today by Cisco and the Madison Technologies engineering team. So without further ado, I'll hand you over to Amit.
Hi everyone, my name is Amit. I'm a Solutions Engineer at Madison Technologies, and today we are going to talk about Cisco IoT in resources or mining. So, mining companies are improving operations and safety by embracing the industrial Internet of Things. The purpose of this presentation is to outline Cisco's IoT solution for cellular and Wi-Fi technology, with a specific focus on products relevant to the mining networks. Let's have a look at how mining is done. A mine is an industrial facility or site where valuable minerals, metals, ores are extracted from the Earth's crust. A mining operation involves a range of complex processes and technologies to access, extract, process, and transport these valuable materials. In this image, you can see the process of mining operations. The journey begins with extraction, where the top layer of earth is carefully removed to reveal the valuable ore. Then, these rocks become smaller for conveyor belts and processing after it goes through the crushing zone. Next comes the processing and concentration, where ore is transformed into a powder once it's mixed with water and chemicals to extract valuable minerals. Then it goes through smelting and refining, where ore is separated from waste using chemical or heat. Mining sites often generate their own power due to their remote locations. Transportation can involve long journeys via road, train, pipeline, or shipping. Our focus is to support connectivity at every stage of the mining process, from extraction to crushing, processing, and concentration, to improve the mining operations. When it comes to supporting the industrial processes and operations in the mining industry, there are fundamental design considerations to keep in mind. The Purdue model, also known as the Purdue Enterprise Reference Architecture or PERA, is a well-established framework used in the industrial automation and control system design. Purdue model is typically depicted as a reference architecture, with each layer representing a different level of control and communication within an industrial system. At the bottom, we have instrumentation layer, which is the home to the OT or operation technology devices used in the mining operations. Moving up to the automation layer, where you'll find PLCs, HMIs, and SCADA system to control the processes. Above automation, we find servers and supervisory systems, SCADA, that plays a critical role in managing mining operation in the visualization layer. Now, then there's enterprise layer, which is layer 4 or layer 5. This represents the corporate network, where administrative and management functions are centralized. The basis of the segmentation is that devices in each layer only interact with each other, or the layer above, and nothing else. Traffic between layers becomes straightforward and well controlled. That way of segmenting these things ensures that a well-organized and secure system is established. Segmentation also offers several benefits, including enhanced security, simplified traffic management, and easier implementation of firewalls. Now that we have discussed the Purdue model, let's have a look at the Cisco reference architecture for mining network. Cisco's mining reference architecture provides a comprehensive framework for modern mining operators. This architecture is broken down into multiple zones, and these zones represent major functions relevant to mining operators. Extraction and transport zone. This zone is where ore is mined from the ground using equipment such as excavators, loaders, haul or dump trucks. Crushing and processing zone. This is the zone where ore is crushed, grounded, and concentrated. Then we have collaboration, remote workspace, enterprise HQ, and remote management devices as well. In this slide, you can see that the vehicle and operators in the extraction zones are connected to the core network. This involves specialized networking infrastructure to ensure reliable communication and data transfer between vehicles and remote operation center. To enable this connectivity, we use something called Industrial Router 1800 or IR 1800 for short. Vehicles in the mining operations are equipped with IR 1800. IR 1800 is a ruggedized industrial router which is designed to deliver reliable and secure connectivity in challenging industrial environment, including the demanding condition of the mining operations. Now, this is a modular industrial router designed to revolutionize the way we manage mining network. The modular industrial router offers connectivity with modules for storage, Wi-Fi, and LTE. This router comes equipped with built-in security and cybervision sensors, providing unparalleled security features to safeguard your mining network. It is purpose-built for moving assets. So when I say it is purpose-built for moving assets, why do I say that? For moving assets, there are few things to consider. Because it moves, you probably need location. So it has a GPS or GNS module. IR 1835 uses the measurements from the GNS receiver, gyroscope, and accelerometer to provide you with the accurate location of the assets when devices are in tunnel. When vehicles and devices are in tunnel, you use these three things to provide you the accurate location of the vehicle. Because it moves, it cannot be rack mounted or DIN rail mounted. So the router is flat and is designed to be installed behind or under the seat of the vehicle. It also has ignition power management. Ignition power management ensures that the router automatically powers on when the ignition is turned on and it powers off when the ignition is turned off. It can also be configured to remain powered on for a set period of time, which is maximum of 2 hours after ignition is off. CAN bus communication. IR 1800 supports CAN bus communication, a reliable serial bus standard that is commonly used in vehicles, enhancing its compatibility and connectivity. It also has edge compute technology, which is IOX. It's the operating system that gives us the ability to run Docker-based application to transform the real-time data for processing. Now, there are 4 models in the Cisco Catalyst IR 1800 series router family. IR 1821 and 1831 are the entry-level and mid-range models, whereas the 33 and 35 are high-end and industrial models. Because these vehicles move, their connectivity needs are different. Let's explore how we connect these assets to the internet, private data center, and the cloud within our topology. When it comes to connecting assets on the move, we have 3 options to consider. First option is to use public cellular network with VPN tunnel. So you still use the public internet, but on top of that, you have an overlay network with tunnel. It provides connection over public internet. Getting VPN tunnel will provide you with security. It will provide you with the ability to route packets to your private network. It will also provide you the ability to isolate private traffic from the public traffic. Another option is to use public network with private APN. That is going to be using public cellular network with a private APN. Now, your phone has a database of all the APN. So when you plug in a SIM into your phone knows which network to connect to. It is based on the APN on the SIM card. Does it have to register to Telstra or Optus? That is basically already defined. And this APN is a reference point or address of your device to get access to the internet. So when we use private APN, this SIM connects directly to your data center. You don't need a VPN tunnel here. And if you have to go to the internet, it will go to the data center and then you can access the internet. Now, the third option is establishing a private cellular network, which is more popular in mining operations. In this scenario, you essentially become your own cellular operator, giving you the full control over the network. However, it's a complex solution that involves spectrum allocation, infrastructure deployment, and radio setup. The main challenge here is the cost, but you gain ownership, coverage control, and the ability to deploy radios wherever you need. So you need to use spectrum. Advantage is you own the network, but and you decide the whole coverage. So you deploy radios wherever you need connectivity. Now let's have a look at the cellular option. A radio signal is an electromagnetic wave that carries information such as voice and data through the air. Wi-Fi and cellular network, and even for radio and TV. These signals have certain frequency and width. Low band, mid band, and high band frequencies are part of the radio spectrum. This is used for the cellular communication. They each have unique properties. So low band, when we talk about low band, these frequencies are below 1 gigahertz. They are good at penetrating buildings, making them ideal for indoor coverage. Some are licensed while others are open for use. License frequencies are allocated by regulated governments or some authority. Unlicensed frequencies are open for general use without specific licenses. Then we have mid-band. Mid-band frequencies are generally between 1 gigahertz to 7 gigahertz. They're commonly used in both urban and suburban areas to provide both indoor and outdoor coverage. Examples are like 2.4 gigahertz, 3.5 gigahertz, and 5 gigahertz. These are used for various wireless technologies, including Wi Fi and some cellular services. High band. High band frequencies are often above 7 gigahertz, and they often offer very high data capacity but have a very limited coverage and are sensitive to obstacles. So they're suitable for dense urban areas and high capacity scenarios. Some examples are like 24 gigahertz, 28 gigahertz, and 39 gigahertz used in the 5G network for ultra high speed transmissions. To leverage the cellular option on IR 1800, we use IR 1800's PIM modules and SIM cards from multiple providers. So we have Cisco IR 1800, and this module is called a PIM module. For Australia, we have PLTLA for Cat6 and P5G S6GL for 5G. Now, this 5G model is universal. Okay, so you can either have one or two PIM modules for the cellular network, and each module has two SIM slots, and both the SIMs SIM0 and SIM1 will be using one radio. So we can have one SIM from one provider and another from another provider, and when one doesn't work, we switch to the second operator. So when you do this, two SIMs, two different operators, first one doesn't work, we switch to the other one, and that provides some level of redundancy. IR 1800 is a modular router, and one of the module is a Wi-Fi module. Now this Wi-Fi module on the 1800 router is based on the Cisco Catalyst 9105 AXI access point. This module has the same feature sets and performance as the AP9105. It has features like support for 802.11ax, which is Wi-Fi 6, support for WGB, workgroup bridge. A workgroup bridge is the ability for the router to be a client or connect to different network. Now, router is the client for existing network. WGB will only extend the network to Cisco devices as it's Cisco proprietary, whereas UWGB is universal and works with all the vendors. The Cisco IR 1800 Wi-Fi 6 module is a pluggable module, and it can be installed on any IR 1800 router. It supports a variety of deployment scenarios such as access point mode, wireless backhaul mode, and bridge mode. Let's talk about GPS now. Since your device is moving, you probably want to know where your vehicle is or where your device is. You can do it with GPS, and you can do it in two ways. If you have an LTE module in your Cisco device, you can use it for GPS. All the Cisco LTE modules that we saw earlier have inbuilt GPS, and that's why you have three antennas, two for cellular and one for GPS. If you have that LTE, you can use it, but if you go inside a tunnel, you lose the GPS signal. So to address the signal loss issues, Cisco has introduced a dedicated GPS module. This module provides precise location data by combining inputs from an accelerometer, gyroscope, and GNS. It also employs a technology called dead reckoning. Now, dead reckoning is a technology that combines GNS data with input from sensors and the ADR chip to calculate the vehicle's position, even when GNS signals are temporarily unavailable. So, if your device is in tunnel or urban canyon, this feature ensures the continuous tracking and reliability. ADR is in effect even when we lose the GPS or GNS signal. So it uses the measurement from GNS module, accelerometer, and gyroscope to provide the accurate location. If precise location tracking is critical, especially in underground scenario, consider using the GNS module for the IR 1800. Lastly, IR 1800 comes with the inbuilt security and cybervision sensor. Cybervision is a deep packet inspection that uses network as a sensor. So Cybervision transforms the router or a switch into a sensor. It inspects the industrial traffic to find weaknesses in the industrial devices and protocols, and it essentially reports to a centralized server to tell that this is what I've seen, these are the risks in the network, and this behavior seems suspicious. Thank you very much for joining us on this journey through the Cisco IoT in resources. I hope this session provided you with some insights. We invite you to join us for the Q&A session where our experts will share their insights and answer your questions. Please don't hesitate to reach out to me using the contact details you see on the screen. Thank you once again, and I'll hand it back to Daniel now.
Thanks, Amit. During the current session, we've discussed the challenges faced in the resources sector, exploring how Cisco IoT technology is improving safety and efficiency in mining operations through, as an example, the IR1800 series of routers. Cisco solutions provide the essential components to tackle these challenges and are leaders in transforming the resource sectors across the various stages, including access, extraction, processing, and transportation of resources. To learn more on how Cisco and Madison Technologies can assist you, feel free to contact your account manager or myself using the provided contact details you see. Finally, we would like to request your support. To enhance the contents of these webinars, we rely on your feedback to guarantee we are providing the most relevant content. Kindly review the post-survey link we will be sending you and share your valuable insights with us, or simply scan the QR code you see on the screen now. Thank you for participating in this webinar, and we look forward to speaking to you soon.